All right, everybody, this is going to be really fun. We're going to create an actual contact page where users can submit contact information and enter a message so that they can contact you online. Now, if we go to the quick start guide on Flask and we go to accessing request data, this actually shows you how to handle it. And right over here in the request object is the code for us to actually grab information from the browser. Now, there's even things like file uploads, so we can get people to load their files and actually send it to our server. But for now, let's just focus on this. I want to copy the code first, and then we're going to talk about what's happening. Let's go to our server.py. We have our basic routes right here, and let's add another one like this. Now, the only thing I care about right now is this part right here. I want to create a new route that I'll name for now submit form. And this is something that we'll actually have to create. It's going to have methods post and get. And again, this is just the default. Get means the browser wants us to send information. Post simply means that the browser wants us to save information. But we won't worry about that for now. We also want to define a function called submit form. And finally, I want to just return for now a form submitted hooray message. So that's our submit form endpoint. But it's not doing anything right now. We're never calling this on the front end, on the browser. So how can we get this to work? Well, let's go to the contact.html and figure out when we click the button, what happens. And actually, let's just search for it. If I go to title page, you see that we have the send button. So when we hit send, we ideally send some information to the server. So let's Command F and look for the send text. And look at that. It looks like it's over here. Let's make this a little bit bigger, just like that, so we see what's going on. We see that we have a button of type submit, and this is the button that we're clicking to send. So it's on line 74. Now, at the top here, we see that we have something called form. And with form, we have an action that we can take. This is standard HTML. When HTML was created, the idea was to display pages, but also using this form, be able to send data to the server. And we do that using this action attribute. And in here, we can put post or get. And if you remember, that's exactly what we have here. This endpoint will be able to accept methods, either get or post. Now, we don't need to get into the details of what get versus post is, but a good way of thinking about it is we can send data with get by simply attaching the information to the URL in here. But ideally, we don't want to send people's emails and message in the URL. Ideally, we want to send it into some body of text that's not so clear and obvious. So in our case, we're going to use post, and I'll show you how this works. So we're going to have an action in here that is post. Now, the way this actually works is we will have to call the submit form, which, by the way, is what our endpoint is going to be, so that with the form, when I click send over here, it's going to run this URL, essentially, submit form, with a method that is post. So the action submit form will be posted when I click send. Let's save this and double check that it works. So I'm going to say submit form here. I'm going to save. And for now, I'm just going to return form submitted, hooray. If we go back and just write some gibberish, let's actually refresh, make sure it's new. If I click send, look at that. I get form submitted, hooray. And you see that the endpoint here is submit form. This was the action that we added in the HTML file. Again, if we go back, open up the developer tools, go to network here. Let's make this a little smaller. If I click send, look at that. In my network, you see that we have the submit form. If I click on it, I get the response, which is form submitted, hooray. And if I go to headers, you see that I did a post method because that's what I said. This is going to be me sending data to the server. You see that the content type is application XWWW form URL encoded. This is just a standard data type that we can send when we use the form tag in HTML. But we don't need to worry about that because we now have access to the data that the user sends. So in the next video, we're going to try and capture the data that I sent to the server and actually read it with our Python code. I'll see you in the next one. Bye-bye. So we were able to submit our form. And ideally, now we have a way to capture that data that the user sends to the server. Once again, if I submit some sort of data and click send, I get form submitted, hooray. Now, if I open up the developer tools and refresh that, you'll see that we have a few errors that we have to take care of. One is this form submitted. So if I scroll all the way down, there's actually one thing I need to fix in order for my server to be able to read this data. We have to go into our contact.html and we just have to make sure that all our inputs, that is email, text, and the text area, have a name attribute. And this is so we can actually grab the data on the backend. I'll show you what I mean. So let's have name here as email, name here as the subject, and then name here as the message. So that if I save this now, and I go back to my contacts and submit this again, well, we'll have to refresh it first. So let's refresh, send some messages. And if I click submit now, and we go to submit form, you'll see that if I scroll all the way down, I have a form data field. We now have email, subject, and message that we actually send all the way back to our Flask application. Because we now gave it these name attributes, it knows what to send. So this is just a quick gotcha. It's just an HTML form standard that we'll just have to add ourselves. Now, if we go to the Flask documentation, we can access these values using the request.form. So if we go back and we go to server.py, we can do something like they say in the documentation. I can say if request, and this request is something that we'll have to import, which I already have done from Flask. So if request.method, which is if we said that the method is going to be post, which if we looked at contact.html, we have the method as post. So if that's the case, then I want you to grab that data by doing request.form, and I can access different values like email, or message, like this. Now, an easy way for us to grab this information is actually to do a method called toDict, which is turning something, the form data, into a dictionary. So we're going to get everything as a dictionary. And then finally, to make sure that we get this data, let's just print data. And we just have to return something. So let's say return. And I want you to return form submitted for now. Otherwise, we'll just return something went wrong. Try again. If we save this, let's open up our terminal and let's go back to the form. Let's refresh. I'm going to close this for now and just submit our regular information. If I click send, form is submitted. I have some errors here that we're going to have to fix soon. But if I scroll a little bit up, look at that. We have email, subject, and message as a dictionary on our back end. We just transferred data to our Python app. How cool is that? Now, the reason we get this error at the bottom is because right now, when I submit a form, I'm still requesting the favicon icon. Now, if we go back to our application, you'll notice that anytime we visit a new area, our favicon is not showing. Well, if we go back to our page, let's go to index.html, we'll see that in the link over here, we're looking for our favicon.icon in static assets. But if you remember, we have our bolt.icon right in the static folder here. So all we have to do is just either rename some of those files, or in our case, we can just move this, call it favicon.icon, and move it into the static assets folder. Like so. Now, if I refresh the page, you'll see that I have my new Bolt favicon. Finally, I want to actually do something more interesting. Once a user submits a form, I want to have a little thank you message. Now, there's many ways of doing this, but the easiest way we're going to do is we're going to copy this entire file. So I'm just going to say duplicate and call it thankyou.html. Now, thankyou.html will be the exact same thing as the contact page that we created, except instead of the form that we have, so let's grab this form information. So instead of having this form, perhaps it will simply say, thank you. I will get in touch with you shortly. Just like that. Now, the cool thing that we can do here is that we can now redirect to the thank you page after they submit the contact form. And the way we can do that is in the server.py, we can import, let's make this a little bit smaller, and we'll import the redirect module. And all we have to do here, instead of saying form submitted, is we can say redirect to what route? Well, we'll redirect to thankyou.html. Like this. Again, because thankyou.html is in our templates, and because our routes are set up to change dynamically, we should be able to redirect to thankyou.html. If I save, and let's say refresh, submit some data in here, click send, look at that. Thank you. I will get in touch with you shortly. How cool is that? And there's many cool things that we can do here, right? Using the curly brackets like this, If, let's say, we ask somebody to submit their username or name, we can say thank you with perhaps their actual name that they submitted. So something like thank you, Bob, or thank you, Ann. But that's something we've already talked about. For now, that looks pretty nice. So I'm able to now submit a contact form. Make sure that we don't get any errors. So if I click on send, look at that. HTML even tells me, hey, this has to be an email. Okay, let's send. And there we go. Everything is working. There are no errors. We're submitting the form with all our data, and we're receiving all that information right over here. How cool is that? So we now have our server.py set up to actually accept information. And now we have our website that's able to, well, hopefully allow us to have clients message you. But we need to do something with this data to store it somewhere. Because now this is in memory. Anytime I close the server, this information is lost. Ideally, we persist it somewhere, or ideally, we store it somewhere so that in the future, we can go back maybe a week later and see who has submitted a form on our website. Let's do that in the next video. Hey, you're still there. I know this is a bit of a long project, but stick with me. We're getting really, really close. You see, up until now, we've built this whole system, right? We have our HTML, CSS, and JavaScript files that we got free templates for. And we also implemented our server so that the browser can actually send data to us, and we can actually save that data and even send a thank you HTML page back once somebody submits a form. Our web page is now something more dynamic than just text that people can read. People can now interact with our web page by submitting a form. And we now have sent this form data to our Python server. But there was a problem that I mentioned in the last video. That is, as soon as the server stops running, or maybe it crashes, that data is lost because right now that information of the form is in memory. Ideally, we write it somewhere on disk so that even if we stop the server, that information is still somewhere on a file, so that this file lives on this computer, just like a file lives on your desktop or laptop. So how can we do this? Well, we've done this before, right? We simply write to a file. Now, we're going to explore this topic a little bit more throughout the next couple of videos, but what I want to do is to close off some of these folders and create a new file in here that will be a text file. And this file will just be called database.txt, just a simple text file. And this database will act as our database where we store information that the server receives. So if you remember, we're going to store email, we're going to store subject, and then we're going to store the message. So ideally, we're able to append or add to this file as people submit the form. So how can we do this? If you want, pause the video and give it a try yourself. Otherwise, let's try this. We can create a new function here, write to file. And this write to file will receive some sort of data that we'll send. And we're going to say with open, again, something that we've seen before. And we're going to open the database. And again, because it's in the same folder as the server, we don't need to specify a file path. We can say database.text. And we're going to open in the mode of A. So that is to append to that file because it already exists. And we'll just call it as database. And in here, we'll say that the file will equal database.write, and then write what we want. In our case, we want to write the email, the message or the subject, and then the message. And we can just extract that from our data, right? That we're going to pass in. So we can say that email is going to equal the data email. Subject is going to equal data subject. And then message is going to equal data message because it's a dictionary, right? And then all we can do here is just do an F string and say that we want first of all a new line so that there's a new line every time there's an entry. And we'll say that we want the email, comma, the subject, and then finally, comma, the message. So that's our write to file function. And then in here, instead of printing data, we can just simply call write to file and pass in the data. So let's save this and see what happens. I'm going to come back to the page and then click send. All right, looks like things have worked, but let's see if we actually wrote to file. If I go to database, look at that. I have my data, that is the email, the subject, and the message. And if I go back to the page, let's say go to contact again, and this time let's do a different email, some text, some more text, hit send, and let's go back. And how cool is that? We now have our own custom database where we store all these users' information. And the cool part is that even if I close the server, I still have this information with me. I can always come back and see who has submitted a form. Very, very cool. And if by now you realize this is how databases work, well, good for you. This is how databases work. This is why you hear the words database. A database is essentially a place for you to store data in a safe way outside of the server, right? Because if your information is in memory, as soon as the computer closes, well, that memory is gone. Instead, a text file like this, even if I shut down my computer and turn it back on, is always going to be on disk, and it's what we call persisting. That is, it persists so that it never gets deleted. But how can we make this better? Well, right now this is just a text file. This is kind of inconvenient and hard to read. Maybe we're creating a startup landing page and we're collecting users' information, maybe email, so we can email people when the startup launches. A better way to create a database is maybe using a CSV file or an Excel file. So in the next video, let's explore that. Welcome back. It's time to learn about CSVs or CSV files. Those are Excel files that we're going to try and create our database in. Now, luckily for us, Python has a CSV module. And we're going to use this CSV module to do the things that we're going to do, which is to write, instead of our text file, to a CSV file. Now, if we keep scrolling down here, you can read all about the CSV module and how to use it. But instead of going through it line by line, let's just code it and show you exactly how it works. So I'm going to create a new file, and this time it's going to be called database.csv. And let's go back to our server.py, and instead of having the write to file function, let's write another function, which will be the write to CSV. And this one will be a little bit different because we have to use the CSV module. So I'm going to actually import it. If we go to the documentation, you can see that we can import it just like this. Import CSV. That comes built in with Python. Now, in here, we're going to do something similar, except we're going to open the file that is the CSV file. We're going to append to this file, and we're just going to call it database, or in our case, database 2. So let's just say database 2 here. Now, we have our data that we receive, but instead of a file now, we have a CSV or a CSV writer. So we're going to do a few different things here. First, we're going to write in our CSV these columns. Now, with a CSV file, by using these commas, so we have the email column, the subject column, and the message column, and the commas essentially say this is the end of this column, this is the end of this column, and this is the third column. So we can keep it the way that we have in the database.txt file. Now in here, let's remove what we have here. And we're going to say csv.write or writer to write to our CSV file. And this writer takes different parameters that we can give it. One is, where do we want to write this? Well, we want to write to the database 2. That is the file that we just opened. The second is a couple of options that we have. Now, if we go to the documentation and we scroll all the way up, you see that we have the writer, csv.writer, and then a couple of options. Now, this delimiter, quote character, and quoting are just options that we can give it that you can read on your own to tell it how we want to write into this CSV file. In our case, I want the delimiter to be the comma. That is, each item in a row will be separated by a comma. And whether we want any quotes around the characters, well, I don't want any, so this can just be an empty string. And then finally, quoting is going to be CSV dot, well, we can just copy exactly what's over here. Let's just copy quoting, CSV quote minimal. And again, just to practice this, let's say you wanted to know what quote minimal means. Again, we just look for that in the text, and it looks like instructs the writer object to only quote those fields which contain special characters. So essentially it's saying don't wrap data in quotes unless we really need to. Again, something that you don't have to worry about. This is more of configuration that you can just copy and paste. And you can read up on your own what each of these mean. The important part is the fact that we're writing to the database with some options. So now we have this CSV writer object that we can use. So this CSV writer can now be used like this. We can write a row, so write row, and this write row will contain the data that we want. And we have that, right? We want to write row exactly like we have above, like this. Except the way we write rows is that we give it just each parameter. So we want to give it the email variable, which we have here, the subject variable, and then the message variable. Just like that. Because we already have email, subject, and message, and the CSV writer is smart enough to say that these are going to be what we want, and we just pass it in instead of parameters actually as a list, like so. So that this row is going to contain email, subject, and message that we extract from the data. Now, if we didn't make any mistakes, this should work, but let's check this. Instead of write to file, let's do write to CSV. I'll save, go open up the terminal, go back to our page, and let's go to contact me again. Let's do w@w.com, some text, and hit send. Uh-oh. We have a bit of an error here. Quote character must be set if quoting enable. So it looks like I have just a bit of an error here. And that is because we actually need a quote character to not be empty in here. So if we're going to quote something, we just need to say, hey, what are we going to use? And in our case, we can use the quote sign with the double apostrophe. Again, we can use whatever we want. You might use this if you want, or this, whatever you prefer. So let's just do a quote that we use in a string. I'm going to save this, give it another go. Let's refresh. Actually, let's go back and submit again. All right, thank you. I'll get in touch with you shortly. And if we go back to our database, all right, we have our new data, but you see over here that we don't have a new line. Let's actually open this CSV file. If I go to database.csv and I double click here, all right, it looks like we're getting our data, but our database, email, and subject are a little bit off. Ideally, these are the labels and headers, and all the rows come after it. Now, let's go back and submit just a different user. Let's go A@W, add a couple of more, hit send. All right, we're adding new rows, but the only issue is that the first time we add a new row, we should have that extra spacing. Now, this is an easy fix. If we go to CSV and scroll a little bit down, we see that we have a write header method. So what we'll do instead is actually just add a new line option and just give it an empty string. So let's just clear everything. Let's just clear everything in here. We're going to save the database and just have server.py. We're going to go back and submit the forms a couple of times just to make sure that everything works. If I go back and go to my database.csv, all right, we have our data. If I open this now, there we go. We have our database right here with our headers and our entries, so that now I can have as many entries as possible and people can contact me, and I'll always have this database for me to check to see if anybody wants to work with me. Very, very cool. But there's one other issue here. That is, right now we're just using an Excel file on the same machine as the server. You see, there's a problem here because now my server and my database are in the same location. So yeah, when the server stops, my file is still saved. But what happens if maybe this computer breaks or something happens to it and I can't turn it on anymore? I've lost my files. Or maybe we have so much data that we want to store. Well, this is where actual databases come in. Databases specialize in storing information. Large-scale applications can use databases to store large amounts of data and then do really interesting things with them, kind of like an Excel sheet, but even more powerful. And on top of it, we can actually have a database on a completely different machine, maybe on multiple machines, so that we're guaranteed not to lose that data. Welcome back. Databases exist for us to store data that persists, That is, data that hopefully lasts for as long as we want it. So we can analyze the data, maybe we can grab it when we need it. And that's what databases do. And most of the time, when you're working with web development, you have the front end that focuses on the browser side of things. So that is the CSS, the JavaScript, the HTML. We have the back end, which is usually the server side, where we can use things like Python, Flask, Django to build a server. And then we also have this database side in the back end, where the server communicates with something like MongoDB, a type of database, to actually store this information. So instead of storing that information on an Excel file, like we have been, we can store it on an actual database, which gives us a lot more power. Now, again, this isn't a course about databases, so we don't need to fully go into the topic. If I go back to server.py, in the submit form, I want to wrap this in a try except block just so we can catch errors in a better way. So after the post, I'll do a try block, and we'll just indent this. And we'll also do a except here. And in here, we'll just return if there's an error, something, or let's just say, did not save to database. So that as we're testing this out, we know if something wrong has happened. In our case, we're going to check for the post. If it's not a post method, then we have an else condition that's going to return something went wrong, try again. And then we are going to try this piece of code. Otherwise, we're going to return did not save to database. All companies store data. From a simple record book of a small business, maybe even on a journal or a piece of paper, to massive companies like Amazon that need computers to store petabytes of data. Now, in order to store this information, pretty much every company, and sometimes individuals too, need something called a database. We saw in the last section how hard it was to have our server remember a new user. Every time the server crashed, the variable would get reset and then it would start all over. Or if we wanted to do a login or a sign-in check and iterate through the emails and passwords, doing a loop through JavaScript, that's inefficient. That's where database come to the rescue. So let's ask ourselves, what is a database? A database is a collection of data. And what we mean by data, there are many forms of them, right? There can be numbers, there can be dates, there could be password hashes, there could be user information. Databases allow us to organize this data in a way that is useful to us. And it makes data management easy. And something came out of that. And it's called Database Management System, or DBMS for short. It's a collection of programs which allows us to access databases and work with data. And it also allows control access to database users. So a DBMS is something in this box. Something that allows us, a tool, a piece of software that allows us to communicate with the database, store information that's useful for us, and also allows us to update, insert, delete, look up, whatever is in the database. And this idea of a DBMS really started to take shape in 1960s. And now it is at the forefront of many exciting things. There's an entire industry of engineers that just work with databases because it is so important. Now, there are two types of DBMS that are really popular right now and that we're going to talk about in this course. And these two types are represented really well by Postgres and MongoDB. Let's talk about the first one, which is relational database. And this is probably the most popular. As you can see on the right-hand side, you see that all of these are relational databases. Postgres, Oracle SQL Server. You may have heard of MySQL, SQLite. These are all types of databases that have this relational database tag to them. And the beauty with them is that they're all pretty much similar. They all follow a same standard format. Relational databases consist of 2 or more tables with columns and rows. So in this case, users is a table, and full name, username, text created at are columns, and whatever values they have here are rows. Each row represents an entry, and each column sorts a very specific type of information, like name, address, or phone numbers. And then the relation between tables and fields is called a schema. In a relational database, the schema must be clearly defined before any information can be added. And if this is confusing right now, don't worry, we're actually going to create these databases so it makes sense to you. If we had Twitter, for example, you can see over here the types of tables that we would have and how we would organize it. We would have a users table, a tweets table, a following table. And we can connect all these information, for example, by connecting different pieces of the table. For example, the username will be the same in the users table as it is in the tweets table. That way, we can say that the username in the tweets table is the foreign key of the username in the users table. And then from user will be the foreign key of username in the following table. Now, things like full name or ID, something that identifies each row in a table, is called a primary key. And we'll go through that later on in this section. All right, so all these databases, we're going to learn about PostgreSQL, but they're all pretty much the same. So once you know one, it's fairly easy to pick up the other ones. How do they actually communicate with a server, with the backend? Well, all relational databases use something called SQL. And SQL allows us to communicate, just like HTTP did, between the front end and the back end. With SQL, we're able to communicate with the database and modify or get or update however we want. And we'll have a video on this topic as well. All right, so that's relational databases. What about the second type? The second type is called a non-relational database or a NoSQL database. And once again, there are many, many different types of databases with some cool names like CouchDB and Hypertable. Now, a MongoDB or a non-relational database lets you build an application without having to define the schema first, unlike a relational database. If we go back to relational database, this schema or these tables have to kind of be predefined, right? We need to know how our app is going to look, make these tables so that once the app is public, we can start entering user information and tweets and followers. With a NoSQL or non-relational database, we can just define it as we go. And they all have different ways of storing this information. So each one is very, very different. And this is another powerful reason to use a non-relational database is that if your data requirements aren't clear at the outset of your project, and maybe you have a massive amount of unstructured data, you may not have the luxury of developing a relational database with a clearly defined schema. They offer instead a greater flexibility in that a non-relational database are more like folders, just assembling related information of all types. Now, MongoDB is something called document-oriented. It stores information as documents. Let me illustrate this point to you. I have my desktop here with two folders. One is a relational database, and here I have users, tweets, profile, following. And you can think of relational databases with this type of storage, where
This folder lives somewhere on a computer that stores this information. And anytime we need to ask a database for something, well, we grab the users. And if we also want to grab the tweets of the user, we find the user that we're interested in, then find the tweets of the user that we're also interested in with the foreign key that links to the users. And we can also find however many followers that user has. We grab that information and display it on our web app. MongoDB, on the other hand, will actually have each user as a document. So if I wanted to grab the first user, well, I just grab this document and it has all the followers, the tweets, the profile, everything is in this one document. And you might be thinking, MongoDB looks like a better choice than having this way of doing things, right? Well, it depends on your need. And that's why databases is such a complex topic. It really, really depends on your situation. You can see this MongoDB way being very useful if you had something like a profile, maybe a LinkedIn profile. But if you needed something where you're working with just following data or just tweets data, maybe with the tweets, you want to see what is the average tweet size. Well, it's really easy to just grab this file and calculate that versus this way where you might have to extract it from each one of the users. So it really depends on your needs. Let me show you another diagram that might be useful. When we look at relational versus non-relational databases, you can think of relational as each table has a blog post, a blog tag, a blog comment, and it links these tables to give you the blog information. Versus a non-relational that stores this entire blog post in an entry and has comments, tags, categories, and all other related data just in one single place. So what does MongoDB use to communicate? If we go back to our example here, we had SQL for relational databases such as Postgres. Well, MongoDB has its own what we call query language. And it is just the MongoDB query language. But they both aim to do the same thing. That is to communicate with the database, provide an easy way for the server to communicate with the database. And in this section, we're going to be talking about that. And we're going to finally connect the dots and show you the power of databases once they're connected to a server. I'll see you in the next one. Bye-bye.
Welcome back. We have our Flask application that saves user contact information to a CSV file. And this is all great. It's working really, really nicely, right? We have a beautiful website. We even have contact forms. But there's a problem here. You see, we're running the browser as well as the server on the same computer. But this isn't real life, because if I give this URL to a friend, they're not going to be able to see it because this address points to localhost. It's saying localhost like this. It's the same thing, but localhost simply means your computer. So it's not like anybody else but us can access our app. That's not very fun, is it? Ideally, we can create this app so we can send it to all our friends, our family members, and possibly future employers. So how can we do this? In this video, I'm going to show you a really fun, easy way to deploy your application or your website online. We're going to use something called Python Anywhere. And Python Anywhere is going to allow us to host our files, that is, all the files that we have here, onto a server that they give us for free. So this is completely free. All you have to do is simply log in, and you can click on sign up. You can see that they have different pricing plans. So you can actually pay for their service, but for a beginner plan where you can create one web application, we can do that for free. So let's create a beginner account. and create your username and password. Agree to the terms? Sure, I've read everything. Oh, somebody else took my username. How dare they? Let's go with Andre N. So again, create your own account. And there we go. We have our dashboard. Now, the way Python Anywhere works is that we need to load up the files on a machine. Kind of like how we have our files over here on our computer, we need to somehow upload them to Python Anywhere's computers. Now, the way we can do that is using GitHub. So I'm going to open up my GitHub account. I'm going to click on New Repositories. And I'm going to create my project here. So let's just call it Portfo, because it sounds kind of cool and all the trendy names are short like this. So this is my portfolio project. I'm going to keep it public and then initialize with a README and then create repository. Now, from here, I'm going to clone this repository. If you have SSH set up, you can copy the SSH, otherwise use HTTPS, which might ask you for your GitHub password when you clone. So all I have to do now is to open up a new terminal. Let's make this a little bit bigger. And say git clone, and then copy and paste the URL so that it clones our project. Now from here, if I open this, we have our web server and then our portfolio, which is our GitHub account. So we can just copy the files here. Now, the ones that we actually need is we need the database, CSV, because these are going to be the files that we want to upload to Python Anywhere. So for now, let's just select the CSV file, the server.py, the static folder, the templates folder, because those are all the files that run our Flask app. Now, if I copy and paste this in here, you might be asking yourself, what about the other files? Well, there's a neat trick here, because these files over here were created because of our virtual environment, right? We have things like Flask installed. We have libraries like Python 3.7. We have our PyCache folder. Essentially, these folders created the virtual environment for us. However, there's an interesting trick here that we can do. We can run a command called pip freeze. And remember, you might have to do pip 3 based on what type of installation you have of Python on your machine. But if you do pip freeze with this little arrow and then requirements.txt, notice what happens as that requirements.txt gets added to my project. Watch this. Do you see that? I get a requirements.txt. And this requirements.txt, if we click on it, we see here that we have the requirements for our app to work. And the cool thing about this is that the Flask and then the Jinja for our templating, which we actually include in our libraries here, can now be used with the requirements.txt to not necessarily upload them to GitHub, but instead use this file as a way for us to install on any future machines any of these dependencies. I'll show you what I mean. For example, what we could do is upload all of these files to Python Anywhere, right? But that's a lot of files and a lot of work. Instead, we only upload the critical files that we wrote plus the requirements.txt, and automatically Python Anywhere is going to be able to install Flask and the Jinja and all the other requirements by looking at the requirements.txt. So for now, let's go back to our desktop and copy the requirements.txt as well into our Portfo page. So we now have all the files that we need for GitHub. If we go back, we can simply go into our Portfolio folder and then simply say git add everything, then git commit and give it some sort of a message, my portfolio website. There we go. And then finally git push origin master. And just like that, if I go back to GitHub and I refresh, look at that. I have all my files for my portfolio project. So using GitHub, we can now upload really easily to our Python Anywhere dashboard. The way we're going to do this is to actually now clone this repo with all these files, and we'll use HTTPS. Let's copy this and then go to our dashboard. Now in here, in the console, we can hit bash. So this will open up the terminal where our computer that is hosted by Python Anywhere exists. Let's make this a little bit bigger. In here, I can say git clone and clone this repo. There we go. And now, if we do ls, and remember this is a Linux machine, so Linux commands like ls is going to work. So we see that we have the readme text and the portfo. So let's go into portfo. And we see here that we have, look at that, all our files on our machine. Now, the cool thing is that if I go back to the dashboard and I go into my files, you see here that in the directories, I have a portfo project, which is my files that we've created. How cool is that? So I now have all the files necessary for me to run the app. But how can we run an app? Well, we have a web app tab. So remember, with the free tier, we get access to one free web app. So let's open up the web tab and add a new web app. So unfortunately, with the free tier, you can't have custom domain names. That is a way for you to say andrenagoe.com or whatever websites you want. Instead, they're going to generate one for you. But that's something that you can look into on your own if you want to pay for it. But for now, let's just use the free tier. So we can select the Python framework that we want to use. And I'm actually going to do manual configuration. We can pick whatever Python version we want. Let's do 3.6 for now because that's what we've been using. And then finally click Next. There we go. We have our Python project at this URL address. But if I click on this, all right, I get a hello world. It's working, but this isn't our portfolio. So how can we make that work? There's a few things that we need to set up. First, I'm going to link you to this tutorial on showing you how to set it up in case you have any problems. But let's go step by step. First, what we need to do is scroll down and enter the source code. So that is, where is the code that we're looking for? If you remember, let's go over here to Files. We have our portfo folder. So what we want to do in the web is to say that we want portfo in here. And it's going to automatically create that link for us. So that's where our source code, our server code exists. Now, if we go back here, we've gotten our code onto Python Anywhere, and then we have to set up our virtual environment. So we have to open up our console. Let's make this a little bit bigger, and then just run these commands. So in our case, because we're using Python 3.6, we're just going to copy this, go to our dashboard, into the bash once again. So that is the computer that we're going to serve our files from. And then copy and paste to create a virtual environment called my virtual env. And while that's installing, our next task is to install Flask. So once again, we'll copy this. So let's run pip install Flask. And you'll notice here as Flask is being installed that we're now in a virtual environment. See here how it says my virtual env, which was what we told it to name our virtual environment. And then the next step is to run this command. Well, actually this command won't do anything because this command, work on, simply takes us to our virtual environment, which we already have created. This is for next time whenever you, let's say, go back and open up the console to make sure that you're always working in our virtual environment. Now in here, if I look at the files, I have my Portfo project, but I can also run using the requirements.txt that we have. In case we have a lot of dependencies, we can actually run this command so that it reads our requirements.txt to install any dependencies. Oh, couldn't open up the file because we have to cd into our Portfo first, and then run this command. In our case, we don't have that many requirements and everything is set since we installed Flask. But this is how we can use the requirements.txt to install all our dependencies. Awesome. So going back to the tutorial, we see that we've set up our virtual environment and we need to go to our web tab to set up our virtual environment so that it knows where the web tab to look for this environment. So going back, we can now go to our web. And I know this is confusing. This is what happens when you do configuration on a website. It's one of those things that you just have to learn or follow documentation. In here, in the virtual env, we will simply, as they ask, add the name of our virtual environment, which is my virtual env. So again, we'll copy this and automatically it gives us the link. Now finally, if we reload our application, it'll take a few seconds, but when it's done and I click, I get the hello world. Something is still not right because we want our server to be running, right? So it serves us the index.html. This video is getting long, so let's take a break and see you in the next video. Now the last step in order for us to deploy our portfolio website is to go to the configuration file right here. When we click on this, you'll get a whole bunch of text. And we can actually delete a ton of these things. You'll see over here that you can have things set up based on what framework you use, like Flask. So because we're using Flask, let's remove all of this code. Just have the Flask section. And we'll remove the comments. So we have import sys. And it has some description here that you can read on your own. But the key thing that we want is to remove the comments from here. Just like that. And then we want to make sure that the directory, so Andre, has a path to Portfo. So remember, our directory was home, username, and then the name of our project. Next, we want to make sure that we give the name as the name of our file. So in my case, it was server.py. If you remember, I have server.py right over here, and we're exporting it as app. So the app is the variable and server is the file name. So if you have a different file name, let's say you have run.py, then you would put run here. So let's do server. Let's see it save. And let's go back to the web. If I reload and run this, we get an error. Now, an interesting feature of Python Anywhere is that we can actually look at the logs. So over here, the log files, we can see what errors or what the server is logging. So in our case, let's look at the errors. Module not found error. No module named server. All right, that's interesting. Let's see why that might be. So if we go back to our configuration file, the reason that we got the error was, well, because I misspelled the path. So it couldn't find the server. So port faux. If I save this, go back to web, reload, and click on our website, holy moly, we have our portfolio project live. That link over there, I can share with anybody and they could see it on their computer. If they're halfway across the world, let's say in India, yep, they can see my portfolio. But you want to know what the coolest part is? Well, the fact that all of our pages work, but also our contact form. So if I do something like, let's make this a little bit bigger so you can see, r2.com, some subject line, and then, oh, somebody's super excited. If I hit send, that worked. And the cool part is that next time, let's say somebody contacted you, all you have to do is actually go back to Python Anywhere. So let's go to a new page of Python Anywhere. Go into the files, and then check out the database.csv, and look at that. You have a new entry into your CSV file. And I can even save the file, I can download the file, so that later on, a week from now, I can check up on the progress and see how my portfolio is doing. And now I hope you're starting to see the power that comes with this. We've created an entire web platform ourselves. We've created the HTML, CSS, and JavaScript files. Well, we used some templates, but we still modified them to our liking, and you can continue to update them and change them to your liking. But we also created a server ourselves that also contains a CSV file that will be saved on this machine. And we moved that machine from just our computers to someplace like Python Anywhere that has a dedicated server or a server space for us, so that it's always running. And this is how things like databases and places like AWS, Google Cloud, Azure, and any other database or server platform works. They allow you to use their machine. They make sure that they're going to run fast, that they're always going to be on. And databases allow you to save things. So instead of saving items in a CSV, we can save it into a dedicated database so we can do more operations or we can store more information. But I hope that opens up the world of web development to you and how everything is connected. In just a few hours, we're able to create a pretty neat looking portfolio, right? I mean, yeah, there was some configuration, some issues, but now that you know how to do it, I bet you see a whole lot of possibilities of what you can do. You can now customize this site whichever way you want. Maybe learn a little bit more HTML or CSS to make the website a little bit more to your liking. Maybe you want to add some JavaScript to make it even more interactive. Or maybe you want to explore different things, like perhaps hosting this application in some place other than Python Anywhere, or maybe creating your own database. The possibilities are endless. So I hope this was exciting to you. This is one of my favorite topics, and it was a lot of things that we covered in a short amount of time. You're not going to be an expert web developer just from a few videos, but I hope this at least shows you the world of web development and how you might want to be involved in this world. Good job getting this far. This was a really tough section. If your brain hurts, don't worry, go take a nap, and I'll see you in the next video. Bye-bye.